So, how do we put this in standard form? There are two ways. One's called completing the square. We'll talk about that in class. Okay? And then we'll probably talk about it again Tuesday, because you'll probably have questions on it. It's one of the somewhat challenging things that you have to know how to do. Okay? But we want to put this in standard form, which is also called vertex form. The reason we call it vertex form, well, here's your standard form, and here's your vertex, right? Since the form was easiest to identify your vertex. However, you can get the vertex here easily. Okay? Your axis of symmetry is at x equals negative b over 2a. Now, I pointed out last time how that's related to the quadratic formula. You just take out that plus or minus square root thing and you're left with negative b over 2a. And there's good sense behind why it is negative b over 2a, because that makes it halfway between two zeros. If the thing happens to have two zeros, and the axis of symmetry has to be there. Whether you understand that or not, this is how you find the axis of symmetry, and the vertex is on the axis of symmetry. Well, negative b over 2a is, b is 3, that's the coefficient of x, a is 2, so your axis of symmetry is at negative 3/4. Okay, so if this is a y-axis and your x-axis, axis of symmetry is the line x equals negative 3/4, and now all you got to do is figure out where the vertex is on this line, and the vertical stretch is 2, so you're going to be able to graph it. Vertical stretch is always what's in front of x squared, or the coefficient of the x minus h squared if you're in this form. And you can see that, you know, if I multiply a times the square of this, I'm going to get an ax squared, right? So when I put it in this form, this is going to be my vertical stretch. Okay? Okay, so there's your axis of symmetry. How do we locate the vertex? Well, again, review what we did last time, but to get the y-coordinate of the vertex, you plug in x equals negative 3/4. So you get f of negative 3/4 is 2 times negative 3/4 squared plus 3 times negative 3/4 minus 25. 3/4 squared is 9/16. Multiply it by 2, you get 9/8. Okay? So everything's going to be in eighths. 3 times negative 3/4 is negative 9/4, which is negative 18/8. So you've got a total of negative 9/8, and minus 25 is minus 200/8. So I believe you have 191 over 8, which if you want to put it in, I'm doing this spontaneously in my head, so check my arithmetic. I'm pretty sure it's 18 7/8. Okay? So the vertex has y-coordinate 18 7/8, so, well, I don't have a very consistent scale. If this is 3/4, my y scale is going to have to be a lot different than my x scale, but we have then negative 3/4, 18 7/8. Okay? And right now I'm not going to go into a lot of detail on how fat or thin the parabola is, because I need to have a more consistent scale here to really illustrate that. To get the equation in standard form though, all I have to do now is say, okay, well, my vertical stretch is 2 and my vertex is this, right? Okay, so the standard form, the standard form vertex is negative 3/4, 191/8. Vertical stretch by factor 2. So I can write down the standard form. So the standard form y equals 2 times x plus 3/4, because you're going to do x minus negative 3/4 squared, plus 191/8. There's another way to get that, but we're not going to talk about that right now. So what you see though is it's real easy to go from vertex form or standard form to the general form, right? All you got to do is expand that square and simplify it. So from the vertex form, which is this, to the general form, which is this, it's just a couple of simple steps. Now, when I say simple, it doesn't mean it doesn't take a couple minutes to do it, okay? But you know how to do it. Okay, now, if you get the general form, to get the standard form, you just use what we know, the axis of symmetry. Plug that x-coordinate in to get the y-coordinate, and you have the vertex. Identify the coefficient of x squared, which is pretty easy, you just spot it. Okay, it's whatever's in front of x squared, right? And there's your vertical stretch, whatever's in front of the x squared. The h and k are the coordinates of the vertex that we just found. Okay? So if you know that, that's a pretty good thing. Okay? Because that allows you to do a whole lot of stuff.